on the first attempt. All right, so my part of the day has two objectives just to get you started here, and we're a little early on what I'm working with you guys on versus what you're doing with James in T2. But I have two goals for you guys as we're just starting to get warmed up into what we're doing. So goal number one is to understand on a big picture how the entire business intelligence process works and can be applied to what you guys are doing with T2. So you can take this underlying architecture information of how the BI system works, not the actual software, but the entire concept of business intelligence from the architectural standpoint can work and then apply to your role as consultants. Then also my secondary goal for you guys, if you so choose at the end of the semester, is for you guys to push forward to become MCSA BI reporting analysts, so certified Microsoft BI reporting professionals, which is a two-part process that we talked about last week. Okay, so I don't want to go too far into the first two chapters of each of the study guides. I just want to give you a little background information to help you all sort of start off on an even playing field, understanding the concept of business intelligence and understanding the concepts of data warehouse driven business intelligence, which is slightly different from what you guys would have learned so far, right? So some of you know about data warehouses, some of you don't. Some of you know about databases, some of you don't. So I want to take a little bit and talk about that, because what you're seeing is a convergence between all these cloud-based data sources in traditional physical data warehouse sources, and then all of them being sort of interlaced together using a BI platform of your choosing. So I just kind of want to chat with you guys a little bit about that. I know not everybody's been through all of this, so for some of you guys it's new, for some of you it isn't, and we'll do a little demo. So I'm going to jump into SQL Management Studio, and I'll show you how to connect a SQL data warehouse to actual Power BI to start building a data model at the end. So you get a little bit of everything to put you to sleep on a Friday afternoon. So give me a second here. I'm going to share my screen with you. And we will pull up a little presentation to start, and then from there we'll go to an actual demo here. So I think James has passed it back to me, so I have the ability to share, which he has. So you guys should see in just a second here there we go. All right, so everybody sees PowerPoint okay? Cool. So I want to talk to you guys a little bit about data warehouses and business intelligence architecture. So the big picture, and I don't know if James has shown you the BI infrastructure that T2 is using or not. I'm guessing he has, but hopefully this will help the concept of data marts and data warehouses and how those connect to front-end BI, how that will help you make more sense of that big picture to understand what's happening. So that's kind of my goal for the day. So the easiest way to consume this as you get into this next level of understanding in data analytics and business intelligence processing is try to look at the big picture, because right now marketing is killer, and you guys are probably being hit with all these different platforms that you hear and they're so cool, and you see them in job interviews and they talk about how their platform is the best solution compared to another platform. So just some of the big hitters that you see, right? So Tableau, everyone knows because it's owned by Salesforce. You guys are working in Microsoft's platform, Power BI. IBM has their own platform called Cognos. Informatica is huge. Sisense is huge. There's one that's coming up really strong called Looker. There's one called Click that's really popular. And the big thing I can help with, I hope I can help with for this, is they kind of all do the same thing. So it really just depends on what specific solutions or bells and whistles or what kind of user buy-in you can get, because in the end, the concept of taking your data, processing your data, and getting information out of it that can be a data-driven source for making decisions is really the big picture. So don't get too hung up. You know, for example, I just had a student that has worked in Power BI for quite a bit. He was able to take a senior position working as a BI analyst, working in Tableau. So he transitioned from Power BI to Tableau. No big deal. Although they work on the front end seemingly different, the underlying infrastructure and the goal exactly the same, right? Data warehouse is a data warehouse. A database is a database. So try to look at it, and I know how it could be a little bit alarming when you get into this because there's so many different technical things to understand. Then there's this base theory that you have to understand that goes back to the 60s in database design, in relational data, in dimensional database, all that stuff. So just try to look at the big picture and what we're going to talk about first before we kind of go down into the the micro level of understanding what we're going to do from a technical perspective. So keep it big, and it will make it a little bit easier to start. So let's just start with the big one, right? Business intelligence. You hear it thrown around a lot, right? We hear that term thrown around quite a bit, but not everybody really understands truly what it is. Usually when you say BI, you think of the software platform, not the actual concept. And this is actually a definition that's taken directly from Tableau, but it's pretty good. The only thing that I'd like to change, so this is actually underlined by Tableau, is that business intelligence combines business analytics, data mining, data visualization, and then the big one that they don't emphasize is the infrastructure of your data. If your infrastructure of your data is bad, everything else is bad. Nothing's going to work, right? So, you hear the old adage, garbage in, garbage out. So it doesn't matter what software platform you use in order to get this done. If your architecture is bad, if your data is not structured well, then you're not going to have anything at the end. So just kind of keep that in mind, right? And another way to look at it, you don't have to memorize this because there's no test, is that you take every system source that generates data that helps you do your business. Your point of sale, your customer relationship management systems, your HR systems, whatever that may be, your security systems, and you look for commonalities in those that can give you insights into how your business is working, and then you visualize those and present them to the people that need them, right? That gives you the value of your data, right? Which is why people consider data a commodity, sort of the big picture. How you do it? It could change 6 times between now and Sunday. Power BI, the tool that you guys are using, didn't even exist when I started at Butler 10 years ago. That wasn't even a thing. Business intelligence tools, though, what we're going to talk about today, have been around since the 60s. So the concept of BI is pretty old. Just business intelligence and self-service business intelligence tools is newer. Not even new, but newer. We'll call it new adjacent, as my wife would say. So here's where it starts to get a little ugly. Understanding the concept of enterprise business intelligence versus self-service business intelligence. And I'm going to venture to say that half of you should know the difference, but I'm not going to assume that everyone remembers because we've slept since then, and I've got a couple of people that have converted to MIS, so not everyone understands it. So let me just quickly give you a little diagram of how this works. And I don't know if James showed you T2's version of this. They're all a little different depending on the nature of the job, but the core sources are pretty much similar. So here's the big architecture standpoint, right? Your business generates data. Everything generates data now, right? So all those data sources are the originating sources that you've got here, right? So your ERPs, your customer relationship management, maybe your website, old legacy systems like your phone systems, you could have security systems, point of sale systems, all that stuff is generating data. Now, without me going too deeply into the architecture of a true data warehouse, think of it like this. All of these systems, okay, are going to take all that data and they're going to dump it into one master database called a data warehouse, okay? So every single thing, every single point of sale system, right? All of that stuff goes into one big old pool, and that's going to store everything that is you. Now, there's a lot more that goes into it than that, but at its basic level, don't worry about ETL or ODS, right? Don't worry about ODS or data marts. Just think big old database. Everything that your business does is in that database, okay? Now, we'll talk more about it in just a minute, but for now, just think of it like that. That's your data warehouse, right? So a couple key things to understand about data warehouses. Every data warehouse is a database, but not every database is a data warehouse. Data warehouses are created specifically with the process of knowing that it's going to do some kind of analytical reporting. So the structure of that database is structured in a way to make data analysis more efficient as the database scales, right? Look at all these systems. So just think about how many different emails Best Buy gets on their website for orders in a day, right? So think about all that data that gets generated, and that's just on placing orders. Don't even think about things like recording how many different things people look at, or how many times people add things to the shop cart and don't check out, or create accounts and then stop, or forgot their password, right? All of that stuff is going into here, and that's just from one e-commerce system. So you're talking about massive amounts of data. And one of the key components of building a database is making sure that that database has the ability to scale, right? And when it scales, it can perform well, meaning that when you go to get data out of it, it can get you that data very quickly. And it's not uncommon to run a query for a database that could take 5 minutes, 10 minutes, just depending on the design of the database and how much data is in there, okay? So now all of that would be done in an enterprise setting away from your user, okay? So the user all the way over here is only going to get access to reports that have been created by an IT person like James, for example, and then pushed out to that person for them to review every day. So if they want something to be customized in that report, if they want something to be changed in that report, then you're going to have to go back to your IT BI professional, which, by the way, that's you guys now, and they're going to go in and redesign that report and then send it back to you. By the way, this is exactly what my wife does, and she uses Yellowfin, which is an enterprise system. So if someone needs a new report at her job, she has to go into SQL and create that report through their Yellowfin system and then push it to them. They don't have the ability to customize, and they're also at the mercy of when she gets that done, okay? So now there are pros and cons to why you do systems that way, right? If you want to have a unified voice, if you want to cut down on the technical acumen that's needed in order to do business, maybe your customers or your user base just doesn't care, right? So they're in the field and they're doctors. As a doctor, I don't want to worry about creating a report. Just give me what I ask, okay? Things like that. So that is just kind of at a high level an enterprise BI architecture concept, okay? Easy thing you guys can do, and this is why I tell my students, when in doubt, use your super awesome camera phone and take a picture. But I am going to record this video as well, and it should be on SharePoint for you guys, okay? So that's just the big picture. Now, you guys are probably thinking this is super complicated, and I agree, which is why enterprise BI is, I don't want to say it's not a popular solution. It's an incredibly popular solution, but it's why self-service business intelligence has become so popular. Because here's the difference. There's the architecture for self-service business intelligence. That whole data warehouse thing is completely gone in this particular model. Now, is it really gone? No. But what happens is, by the way, BYOS, bring your own software, is that here your users, okay, are going to connect to some kind of BI service, like a Power BI or a Tableau or whatever, and then they use that to directly to connect each one of their data sources, right? So you've got an ERP, I can directly connect to it. I've got a CRM, I can directly connect to it. I can directly connect to text files, right? And you guys have all done that in 378, right? We connected to databases and CSVs and XML files, all these different things. But remember, you had to do something. You had to create a data model when you did it. You know that data model is basically the data warehouse, okay? So when you go through and work in that BI software solution, the cool thing about SSBI is that in many ways, you're splicing together your own mini data warehouse directly connected to the sources, and it cuts out the need for high-end IT professionals to do a lot of legwork. Now, is it the end-all solution? It is not, which is why you start to see hybrid solutions, which is really what you guys are doing with T2, right? They're working in, I want to say, AWS. James, are you still there? I think you're still there. He might not be. Oh, he is still there. Are you guys in AWS? Yeah.
Can you hear me? We are in Oracle, actually.
Oracle. So, I mean, just full-blown data warehouse then.
Yep.
There you go. Okay.
And we're looking to move to Azure here in the next 2-3 years.
There you go. There you go. So cloud-based solutions. And we're going to show you how to connect to that as well. So I'm going to show you how to connect to just a regular SQL database in a minute. But what you'll see, you'll start to see these hybrid solutions because you've got these massive data sources. And even though Power BI, as great as it is an awesome tool for the self-service solution, not everyone is going to know how to directly connect to an Azure or a SQL database, which you're going to see in just a second. So you'll start to see these hybrid solutions. But really, the big benefit is each one of these guys, all these guys here, have the ability to directly connect to their data, right? Connect, transform, share is the mantra of SSBI, and work with it without the need of intervention of an IT professional. So you have faster connectivity to your data, but you have the functionality of what would have been a SQL analysis services back in the early 2000s. So it is a powerful tool, and it's caught on a lot because the visualizations are beautiful, and at the very basic level, it's not that hard to do. So if you didn't have a ton of data, if you don't have a huge business with multiple information systems, you could pretty quickly get into BI and get up to snuff pretty quickly. Okay. So little nod back to the 90s. So that was kind of a high level picture. I'm guessing no one understands this but me and maybe James. So I want to break it down a little bit to its base level on why that's important. Anybody actually know who this is besides James? Probably not. I wouldn't. My feelings aren't hurt.
Oh, come on, guys.
I know, they're not going to get it, but I like you. Sometimes you got to break it down. So I want to break it down at its simplest level for you guys, right? No matter what the information system you use, it's real simple, right? You got acquisition and you got analysis, right? You got something that collects data, and then you got something that takes that data, analyzes it, and visualizes it. Okay, so those are the two things you're dealing with. Some source is creating data, you're collecting it, you're putting it somewhere, and then something else, maybe some different tool within that platform is taking that data out, analyzing it, visualizing it, taking it where it needs to go. So your operation systems are what your collection data would be, right? So your point of sale, your Internet of Things, integrated automation manufacturing systems, your customer relationship management systems. Oh, I got a question. Yes, it is. It is MC Hammer. Very good, sir. We got one person that got it. Excellent. That makes me a little bit happier on a Friday afternoon. Um, so think of it this way: your point of sale systems, all that data is going into your data warehouse, and your BI solutions are getting that data out and making something out of it. Okay. So quick backtrack on why databases are so important. And this is the part that gets lost when you talk to people that are just getting into business intelligence. They separate the concept of BI from databases. In databases and business intelligence, they go together like peanut butter and jelly, cars and tires. You got to have one to have the other, okay? So, and that's what we're kind of the big picture of today is the importance of databases, data warehouses, and how they connect in the business intelligence platform, which, by the way, that coincides with chapter 1 of your study guide for the Microsoft exam. So chapter 1 in both books, both 79 and 78, the first chapters are dealing with data acquisition, okay? So remember, you have data acquisition and data analysis. The first two chapters, chapter 1 of each book, is data acquisition, okay? And when you acquire data, where do you put it? You put it in a database, okay? So if you took 265 with me, you learned a little bit about the Harvard Mark II, which was the predecessor to an actual computer. That was the late 40s, 1947. By 1950, you had your first stored computer program. Now, if you've got a computer program that can be stored, that means that you've got data that can be stored, right? And we couldn't store very much of it. It used to be stored on punch cards, actually. So by the 60s, a guy named Charles Bachman designed the first concept of a database, but it's not the kind of databases you know today. This database was called IDS, an integrated database system. It was just one big old flat file that had links between things that were important. That took off pretty quickly because obviously as our ability to store data grew, our ability to do something, our need to do something with it grows with it as well, right? So that generates demand. And by the 60s, there was a huge demand to standardize database design, these IDS systems, right? And we've learned a little bit about the history of technology back in 265. We talk about how when you standardize things, they really take off. That's when things become popular, right? If I were to ask you what side the accelerator is on, you'd know. If I asked you what color means go, you would know. What side your blinker is on in your car, you would know, right? Because all of those things have been standardized, okay? And in computer design and in technology design, when things first come out, they're not standardized. They usually are proprietary when they're first created, but when they do become standardized across multiple platforms, that's when they take off. And what happened with database design in the 60s is they came up with a language that was standardized called Common Business Oriented Language, aka COBOL. And people joke about it all the time, especially now, because some of these COBOL-based systems are actually still in production from the 60s. Like, for example, at the power company. A lot of that stuff has been around for a long time, but the people that created them have retired. So finding someone that still knows how to use COBOL is actually fairly tricky to do, okay? And we had COBOL for about 10 years, which in the grand scheme of things isn't that long, until the 70s. In the 70s, a guy came along by the name of Edward Codd. He is sort of like the godfather of database design, and he introduced a new model called the Relational Model of Database Design, or the RDBMS, Relational Database Management System. Inside his design, he came up with tables, of structured data that were related through common fields. Now that should sound pretty familiar, right? Because that's exactly how we do it now, with the exception of when you get into unstructured data due to social media and the internet, which is a whole other story. Now, the underlying language that drives this RDBMS is called Structured Query Language, aka SQL, which is what we use today. Okay? Now, that whole concept of SQL, a big part of it was the analysis that came from it. So you could make the argument that business intelligence has been around since the 70s, right? Because SQL analysis services is built into SQL. Now, Power BI, the new SSBI, no, that's much newer. But just the concept of using all these related data sources to come up with a big picture and make a data-driven decision, 70s, really old. Okay. So, quick refresher of relational database systems, and I know you all took 265, so you know this, but I'm just going to hit you with a quick once-over to remind you guys, right? So, modern database systems, no matter what they are, SQL, DB2, Oracle SQL, Access, whatever it is, they're comprised of tables, okay? So, all of your data goes into tables. Tables are comprised of fields. Fields have values, and a group of related values is called a record, right? So in your phone, when you pull up somebody's information, right? So you go to contacts, you pull up their information, that's a record, right? And all those related all those related data points, that's all part of the record for that one individual person, okay? Records inside structured databases have to have primary keys. Primary key must be unique, and a primary key cannot repeat. Give you an example. There are about 1 million different numbers that are assigned to you as students, or just as people, right? Those numbers are just totally made up, but you know that they're important to you, right? So your social security number, your driver's license number, your student ID number, your credit card number, they're all totally made up. Those numbers are your unique identifiers inside the database of whoever created what you're using. They have to be unique. So like my credit card and Carmen's credit card can't be the same number, and they cannot repeat, okay? And we'll explain what that means as we get into data normalization a little bit more. So now that's all old stuff. Here comes the new stuff, okay? Along with the introduction of this structured database system, COD also introduced the concept of data normalization. Data normalization is remarkably challenging. And when I first talked to you guys, I probably told you there are 5 normal forms, but actually there's 6, because you have an unnormalized form as well. But what you'll find when we go through the concept of data normalization, which you did that in 265, and here's the part that will surprise you. If you're working in BI, either Enterprise BI or SSBI, even in Excel, you remember you got to build something called a data model. That data model has to use normalized data. And this is one of the things that people get lost on. So if you're trying to truly work in BI and not just do something in Excel or do something on a flat file that's got a cool picture on top of it, you've got to work with normalized data tables. And that process is done on paper with a data dictionary and an ERD, an entity relationship diagram. It's not done in a system at first, okay? So it's done through a process called normal forms, and you guys have been through some of this already. And what you should know, hopefully, is that in most business applications, 3rd normal form is enough. Very seldomly do you have to get all the way up into the 6th normal form, 5th or 6th, which I usually refer to as Stephen Hawking's confusing. But even though I said most of the time you only have to go to the 3rd normal form, today we go past the 3rd normal form. So we're going to go a little farther into it than you have before. So this is new to some of you guys. Okay, so I want to talk to you a little bit about that and why this is important. So if you look at just 3rd normal form, this is the actual definition that they give you for it. Good luck with it, right? A relation is in 3rd normal form if it's in 2nd normal form and every non-prime attribute of the relationship is non-transitively dependent on every key in the relation. How does that feel? Not great. See that, and that's 3rd normal form. It just gets worse, right? So I want to actually talk to you about what advanced normalization looks like and the data structure that goes into it as you get into something called KIMBALL methodology of database design, which is what goes into making data warehouses. Okay. So data warehouses are databases, right? But they're special databases, and they're designed to scale. So you've heard me say this a little bit already, right? So all databases or all data warehouses are databases. Not all databases are data warehouses, right? And you understand what they're for. They're designed specifically for analytical purposes and to scale. So as your company ramps up, you can put more stuff into it, right? Okay. So if you get into data warehouse methodology, there's really only one force in the world that people accept for data warehouse design. And there's some alternative options to it. But when you really get into it, it's pretty much accepted by everyone, including Microsoft. It's called the Kimball methodology. And I've been talking to you guys about Kimball methodology for a little while, and I just never said the word Kimball because once you get into deep data methodology, it can become confusing for underclassmen. But in 378, when you heard me talk about dimension tables, and you heard me talk about fact tables, you heard me talk about linking tables, those are all aspects of Kimball data warehouse methodology. Okay. So in order for you to actually build something in Power BI, you have to understand that because that's what Microsoft expects you to do. And if you do choose to take the test, the BI reporting analyst test, they're going to make you create data models inside Power BI. Those data models are implied to be based on the Kimball methodology of, here we go, I've got another question that popped up. Kimball methodology of data warehouse design. Sorry, I see it popping up in here. I'm trying to get it. Question comes up. By fact tables, do you mean truth tables? No, not exactly. So a fact table, think of that like, unless in actuary, a truth table is something that's the exact same thing. I'm talking about a fact table. Specifically, it's just called fact table. But let me tell you what a fact table is, and maybe in actuary, a truth table is the same thing, because I'm not exactly sure to answer your question. The question that came up is, when I say fact table, do I mean truth table? I don't know in actuary what a truth table is, but I can tell you though, in the Kimball design, a fact table is a table that holds all of your measurements, not your measures, your measurements. So let me give you an example of what I mean. If you have a company that's e-commerce and that company sells things, your fact table would hold all of the actual sales data. So think of it like the facts of what you're doing. So maybe that is a truth. I mean, it sounds like it could be a truth table. I've just not ever, Kimball doesn't refer to it as a truth table. They refer to it as a fact table. So maybe it is. Scott, is that what a truth table is to you?
I was thinking of the truth table we went over in class, in which it was like for certain conditions it was yes, no, yes, no, or maybe I'm getting it.
Oh, sure. So no. So that's completely different. So that's that. So you're talking about Boolean logic?
Yes.
Yes. No. So now those are just basic computer concepts. So no,
Okay.
no. So this is different. I do understand what you were talking about. So no, these are two separate things. A fact table in database design is the table that's got all of your measurements in it, not your analytics measures, which we'll learn how to do with KPIs, key performance indicators, your actual measures. So if it's sales, it's your sales. If it's donations, it's your donations. It's the stuff that you're actually measuring. Is your fact.
Yeah, and perhaps this, and I jump in here. As you guys look at your different domains, for someone who has the financial domain, it's all of the financial transactions. Now, those financial transactions might have a payment method of Visa, MasterCard, American Express. The Visa, MasterCard, American Express, the details, the descriptions of that would be a dimension of that fact that somebody paid $10 for something. Right, that fact, that record, for a citation, the fact that we have a citation written, that's a fact. The fact that we have a permit sold, that permit is a fact, and those go into the fact tables. All the different ways in which we look at that, evaluate that, that's when we get into dimensions, and that's what we're about to get into here in a second.
That's right. That's what's coming. So he's absolutely right. He's absolutely right. I told you he's one of my best students. Dimension tables. So when you talk about dimension tables, I'm going to show you in a second. Easy way to think of it like a lookup table, right? So think of it like something that factors into the measure. So for example, if you've got sales, right, and you've got another table that's got the list of all of your sales agent information, right? That sales agent may have contributed to the sale. That would make it a dimension of the fact table of sales, which I'll show you in just a minute. And I've actually got a live version to show you here in just a second. So at its base level, though, just think dimension, think facts. And if you get a little confused, if nothing else, think of dimension tables almost like VLOOKUP tables, right? So if you see a sales ID and you want to know the guy that sold it, you can go to the dimension table and it'll tell you that information. Now, there's a lot of different reasons why you do something with dimension and fact tables. A lot of it deals with efficiency and how the database functions and how quickly it can query data. But the more you get comfortable with it, the more it will help you if you want to take that Microsoft exam, because they will make you create data models using this methodology. They will also refer to it, and they assume that you just know. So they'll say fact table, and they won't even say fact or dimension. They will actually use the Hungarian notation version, so it'll just say DEM or FCT. It won't actually even spell the whole thing out, and it's assumed that you know what that is. And I'm going to show you in just a minute here. So now, how are these related tables connected? They're connected through relationships. These are things you should be fairly familiar with. You've got three pretty common, well, two really, that are pretty common relationships. One not so much, but you can get it, which is one-to-one, one-to-many, and many-to-many relationships. Only way you can have a many-to-many relationship is if you have multiple relationships between two tables, because remember, primary key cannot repeat. So if it's a many-to-many relationship and the common field is also a foreign key, which is all stuff you've learned from 265, that wouldn't be able to be a one-to or a many-to-many because the primary key would be repeating in both tables. Okay, and I'm going to show you in just a sec. So I just want to give you a little backtrack, and you've learned a lot of this already. So let's go into more modern BI architecture, right? So I had to walk you through some of the easier stuff to get to the part that's a little more jarring, right? So what does it look like when you really start to do this? And I'm going to venture to say this is a lot more like what T2 is doing versus some of the basic things that I showed you before. So over here, you've got all your operational systems, right? These are the things that are pulling your data in, right, into a data warehouse. And now here's the part that's really cool with your data warehouse. If you're using self-service BI over here, you've got your user that can just go through this server to connect to your data warehouse, and it's going to analyze using that reporting software. But if you got your power user, and we're going to show you how to do this in a minute, you could write direct SQL queries that pull data from your data warehouse, right? So you bypass this entire service. You can bypass the data mart. By the way, what a data mart is, think of it like departmental databases. They make it a little bit easier to process data, to get the data faster. So for example, if you work in finance, you may not care about data from marketing. So by having these smaller data marts, you can shop for data the way you want to, is an easy way to think of it, okay? And I'm pretty sure T2 uses the data mart structure as well. I haven't looked at their schematics in a little while, but I'm pretty positive, okay?
We do.
Yep, that's what I thought. So just kind of a ballpark of your power user versus your casual SSBI. And remember, the big serve of Power BI is that you don't have to have training like the training you're getting right now in order to use it. I mean, anybody can pick it up pretty quickly if you're just doing basic visualizations. Now, what we're talking about is structural design, which is a little bit bigger because you guys are going to be BI analysts, okay? So why is this important to you? Like all the stuff that I just told you, because I'm sure that most of you have already worked in Power BI and it didn't seem as complicated as all the stuff that I just told you. Well, if you think about what you can do with Power BI when you get into your own environment, especially as you start to transition into cloud-based solutions, right? So as we switch into AWS or Google Cloud Platform, you have the ability to design a data model that works the same way as a data warehouse on your side. So as you go in and connect to multiple data sources in Power BI, as you go through and create that data model, right, create those connections and the fact and the dimension tables, all that stuff inside Power BI based on queries, you could, in a sense, create your own version of what would be an ad hoc data warehouse. And that's another cell. Why that's important, as your data goes up, the speed in which you access that data tends to go down. And especially now, since the entire world works from home, you'll see there's been a huge stress on the internet already. There's already been a huge stress just because everyone's working from home, everybody's streaming everything. Being able to optimize to get maximum performance out of your queries is a big deal, okay? So understanding that will make things easier for you as you get into some of the micro things that they'll test you on the exam, on specific types of queries and different kind of joins, right? Inner versus outer versus anti-joins, all the different things that hopefully Dr. King talked to you guys about, and if he hasn't, he will soon. Understanding this will make it a little bit easier for you. So demo time. What does this actually look like? So we'll get into something that's more interesting here. So let me get out of here and let me see if I can change my share for you to just my desktop. Maybe. Huh. Screen. Oh, there we go. All right, so here's my whole screen. We're going to get out of SharePoint. It's my messy desktop, and I'm actually going to go into SQL Server Management Studio. So we're going directly to the source. So on my computer, I've got SQL Express set up. So it's going to take a second since I've got a lot of things cooking all at once. There it comes. And I've got two different databases actually saved on my computer. So I've got the database server, right? And that's the database engine that's running right here. And this happens to be the name of my server, which I'm going to need in just a second. So let me grab that. Okay. And I'm going to connect to the server first. So the server's running on the back end. SQL Server Management Studio is basically the management tool that allows me to connect to the server. Okay. On that server, I have two different databases running. One's a data warehouse design, one is not. So I just connected, okay, to my SQL server using Server Management Studio. And you'll see when I go to databases, I have two databases. So there's one regular version, one data warehouse version. So if I look at that and I look at the tables in this data warehouse, you'll start to see all these things. So DBO is database object, and now you're seeing this call for dimension tables and fact tables. So if I wanted to get even more interesting, so I can create a new query, and I'm still doing this directly in SQL. So new query, it's running slow because I'm recording this and running Zoom. And we'll grab my, I don't know, let's grab my reseller information. We'll pop that in. And let's just see what's in there. So I picked a bad one. I should have known. Let's not do that one. Let's grab a different one. Let's grab our, internet sales, sales quota, survey response. Let's try our prospective buyer. Let's see what's in that one. I should have checked some of these out. So this is just a free database, a data warehouse that you can download from Microsoft as a tool to explore in. There we go. So when I look on the inside of this, I can actually see all the aspects of this table. So there's my columns, right? So there's my fields. It's telling me the different metadata that goes along with it, the field size, the different types of scales, right? See all that stuff floating around in there, and that's just inside true SQL, okay? So what we're going to do, though, is we're going to use Power BI, and we're going to connect to this database and pull this data out of it to shape, okay? So instead of me doing what you would do as an enterprise user, so as an enterprise user, you would live inside the environment that I'm working in right now. You'd create reports, you'd push those reports out using Management Studio. But instead of doing that, now I've got that database that I've got saved here. I'm going to exit it. I don't need to save my beginning query here. And I'm going to go into Power BI. By the way, you could do this in Excel as well. So open up Power BI, and we're going to use it as a different tool. So remember, we're going to bypass that whole process and direct connect to the database. So remember, so there was the server. On the server, there was a database. I had to use management software to connect to that database. So I'm just going to go directly to get data. It's going to pop up in just a second here. It's a thinking. There we go. I'm going to go to database, and I'm going to connect to an SQL server. So when I do, I cheated a little bit, right? So I looked up the name of my server. That's it. So that's what's running localhost on my machine. I'm going to go ahead and connect to it. It's probably going to tell me I need credentials. And there are the two different databases. So now why did that happen? Why do I have two different databases I'm seeing? Anybody know before I actually tell you? Why are there two different databases?
Different data sets?
Well, yes, you're right. There are two different data sets. So here's what I did. Now, it's not just that there are two different data sets, though. Power BI didn't connect to a specific database. Power BI connected to the SQL server. So now I need you to understand that, because on the Microsoft exam, either if you're doing the BI version for Power BI or the Excel version, first you connect to the server. So when I connected to the server, there are two databases running on this server, okay? One's the AdventureWorks regular, and one is DW for data warehouse. So now when I look at that, there's all my different stuff, right? course, my memory fails me, so I don't remember what I just looked at before. I think it was something like prospective buyers, maybe. No, it was, let's grab our fact table of survey responses, see what's in there. So now when I connect to that server and I look at it from Power BI, it's sort of working the same way that Management Studio would work. So Power BI is eliminating the need to use SQL Server Management Studio. On top of that, it's making it much easier for me to function. So if I click Transform Data, there we go. I can go into this and manipulate it in any way that I want. I can remove things, I can add things, and it's going to use that M code for mashup to create whatever I want. Once I'm done with it, I close and load, and that now becomes part of my data model inside of Power BI. So I click Close and Apply. Now I go to my data model. Oh, it's going to take a while. And there you go. So here's one table that could be part of a potential much larger data model that you'll see, right? And I believe James showed you something called a data dictionary as part of T2. When you go through and do this, you would create the data dictionary that shows the relationships and all the tables that you're going to use inside your model before you ever go in and do what I'm doing right now. Okay, so it would start with that. So for now, big picture takeaways, because we're about done here. One, you understand the difference between a regular database and a data warehouse. Okay, you understand the basic concepts of how data warehouses work. Okay, you understand what BI does for you, both enterprise BI and self-service BI, just conceptually. You learned a little bit about the history of databases. Okay, we talked about Kimball methodology of data warehouse design. And I showed you how to directly connect to an SQL server to pull data from an SQL database instance running on that server. So that's just a warm-up. So that's kind of old stuff with a little bit of new stuff mixed in. But as you guys get ready to read through chapter 1 of your study guides, know that it's all about data acquisition. Remember, acquisition and analysis. So the first chapter of 78 book, first chapter of 79 book, both all about acquisition. That's what we just did today. So good place to stop on a Friday afternoon. Whew. Who's got questions besides who MC Hammer is? More than we bargained for. Good deal. Yes, sir. Carmen, just go ahead and you